Hello scholars, welcome. Mr. Hinkle here. This lecture we are going to look at what are minerals. Now minerals could be a whole wide range of things. They have common usage of terms, but in the space of our emphasis here, what we are looking at is minerals in terms of geology. What are geologic minerals? Not the natural vitamins and minerals that promote health and wellness for optimum bodily function. All those do come from the earth also. But this is most specifically, what are the raw earth materials that make up this earth that we live on? And the answer to that question is minerals. So what we are doing in this lecture is defining the fundamental characteristics of minerals, discussing what information minerals convey, and then making the connection between minerals and rocks. What's the difference between a mineral and a rock? Well, we'll talk about it. So by definition, a mineral must contain these 5 characteristics. It must be naturally occurring, and that means it's formed by geological processes, as opposed to being synthesized in a laboratory by humans. Minerals must be naturally occurring. Minerals must be inorganic, meaning that they are not alive, mostly. A caveat in the definition, what the heck is going on here? Well, would you consider a snail to be alive? Yes. Would you consider the shell of a snail to be alive? No, I don't think so. And this goes for many creatures in the sea and in terrestrial environments. So minerals are mostly inorganic. Minerals are not alive. Humans are alive. We're not minerals. Trees, they're alive. They're not minerals. Minerals must be solid at room temperature. Which means that if it is a gas or a liquid at temperatures on the surface of the earth, it is not a mineral. Minerals are solid substances. They have a regular crystalline structure and a defined chemical composition. This is really discussed in the chemistry of minerals lecture. But it's important to put this out here in our definition of minerals, chemical composition. A chemical composition is basically a chemical formula. Quartz, SiO2. Halite or table salt, NaCl. Elements combine to form compounds, and in these bonds, there are arrangements of those elements that give them a crystalline structure and also define a chemical composition. So these are everything that defines a mineral. 1985, a mineral is an element or chemical compound that is normally crystalline and that has been formed as a result of geological processes. Standard definition, but here are all the attributes that a mineral needs in order for it to fully, truly be a mineral. So, is it a mineral? We've got ice. At normal Earth conditions, ice can exist. Ice has a crystalline structure, a chemical composition, H2O. Ice is not alive, and ice is formed by natural processes. So yes, ice is a mineral. Plastics of various types. Plastics are made in labs by people, so no, it is not a mineral. Whoop, salts, formed by the earth. Yes, salt, yes, salt, yes, salt, yes, salt, yes, NaCl. Okay, salt is a mineral. Here is an actual mineral of biotite, meets all the credentials. This one, diamond, cubic zirconia. Can't even tell. That's how good the fakes are. And it's a fake cubic zirconia because it's made in a lab. So diamonds are minerals while their counterparts, cubic zirconia, are not minerals because they are not naturally occurring. Amethyst. This is a variation of the mineral quartz that comes in the color purple, and it grows inside of a rock in a cavity, and they're very beautiful, really cool. But are they a mineral? Yes. Yes, they are. So minerals tell us the history of the earth. Minerals are the raw materials of earth, right? And what geologists do is learn to read the rocks, because a mineral will tell us conditions at the time that it formed, at the time that the elements bonded with each other to form that specific mineral. That is going to reflect temperatures and pressures and plate tectonic setting and a whole other slew of information that allow us to get to the question, what is the history of the earth? How do we understand how our earth formed and what's happened in the last 4.54 billion years since the earth was created? Minerals can tell us environmental conditions, history of formation of mountain ranges, paleoclimate, which means what was the climate like in Earth's history, the nature of ancient seas and organisms that lived in them, temperatures, pressures, compositions, all of these things. So we get Earth history. My favorite question is, how do we know that? And my favorite answer is, the rocks tell us. But what are rocks? Well, rocks are aggregates of minerals. There's a lot of minerals on Earth, over 5,400 discovered and more being discovered every single year, but fewer than 50 of those minerals are common and join together to form rocks. So, a rock is an aggregate of minerals. Or mineraloids. Rocks can be certain substances, like obsidian or volcanic glass. Does not have a crystalline structure, but it is made from geological processes, so we call it an igneous extrusive rock made of mineraloids. Granite, my favorite rock. Primary rock type of our beloved Sierra Nevadas here in California is made of the minerals quartz, potassium feldspar, hornblende, plagioclase feldspar. Throw a little bit of muscovite and biotite mica in there, and what do you know? Granite. But this is an aggregate of all the individual minerals, and all those individual minerals meet these criteria: natural, inorganic, solid, have a crystal structure, and a chemical formula associated with them. Minerals form rocks, and rocks, you could say, are earth materials, right? And it's layers of classification, but there are three types of rocks. We've got igneous, sedimentary, and metamorphic. This is the basic rock cycle. It gets much more complex, which I discussed in the rock cycle lecture, but these are our three basic types of rocks, identified by how they formed. Rocks are made of minerals. Minerals make up rocks. Rocks are classified into either igneous, sedimentary, or metamorphic by how they formed. Crystallized from magma or lava, deposition, burial, and lithification of other rocks, or recrystallization in solid state. Giving us examples, but no matter what type of rock it is made up of minerals. Minerals are inorganic, naturally occurring substances with a specific chemical formula and crystalline structure. They tell us about the geologic conditions at that time of formation and help us to understand our Earth history. And minerals are the building blocks of rocks, are basic Earth materials that recycle throughout Earth as time goes on. Thank you so much. I'll see you in the next one.